Solving equations with three operations. So, in our previous parts we've looked at solving equations like this, like this, like this, and then we looked at equations like so. Now, the equation you see there referred to in part 3 has three operations, and we had to be careful with this divide. If you're not sure on these, please go back and watch part 3. So, let's look at an equation with three operations. Now, let's look at our order of operations and then go about our business of reversing those operations. We have a bracket for the first time. We have a division and we have a subtraction. So to go the other way, we're going to add, multiply, and then do the bracket. Or are we? Well, actually, we're going to change that. So, why do you think I want to change that order? And rather than do the bracket last, do it first. And why does it not fit with the normal order of operations? Okay, here's a clue. Three something equals 12. What goes here? Okay, let me write that differently. If I wrote, instead of a block, I wrote y. What would you tell me y is worth? Well, you'd probably divide by 3 and get y is 4. But y could have just been a block. It could be a block is 4. Why did I draw the block? Well, look at the line above. 3 lots of this equals 12. So what am I going to suggest we do first? That's right. I'm going to suggest we divide both sides by 3. This side becomes 4, and over here this multiplied by 3 will be gone. So I'm left with just what was in the bracket. Now, have a look at that again. This side we're fine with. This side is times by 3, so it's gone. And the bracket goes because there's nothing to do outside anymore. So actually, doing the bracket first and putting that into our bit mass wasn't necessary. So we're going to have to be careful here. Like we saw with the division earlier, it's not as simple as just reversing the operations. It can work really well. And in this situation, it's going to work really well. But it won't always be perfect. And we'll go through several like that to see now. So here, next we would add the 2, going back to our plan. Then we would multiply by the 5. Now, you can do this question in several ways, and this is where you're going to find it gets confusing. Because now I'm going to do the same question, and rather than do the bracket first and change our rules, I'm going to get rid of the bracket straight away. And we do that by expanding the bracket. And it's worth watching the video on expanding brackets to help you here. So 3 times x over 5, well, that's the same as 3 over 1 times x over 5. 3 times x will be 3x, 1 times 5 will be 5. 3 times minus 2 is minus 6. Now, provided that the steps I do follow the rules of maths, I'm still going to get the same answer. Now I've expanded the bracket, I still have 1, 2, 3 operations. And if I focus just on these letters of BIDMAS, that's going to help me. I've got one of these and one of these. So, subtraction is definitely last, so I'm going to add first. I'm going to add 6 to both sides. So the minus 6 is gone. I'm then going to multiply by 5 to get rid of the fraction, because I like to get rid of the fractions. That takes me to 90, and that takes me to 3x. Then when I divide by 3, lo and behold, I come out with the same answer. So, it doesn't matter which way you do it, as long as you follow rules. You can see this as 3 multiplied by this equals 12 and divide by 3, or you can expand the bracket and then solve it. These numbers made this method, in this case, a good idea. Why do you think that is? Well, 3 times something equals 12 gave us 4, which is an integer solution. If this answer here had come out as a complicated fraction or decimal, I think we would probably try and avoid it. So, 5 lots of x minus 2 equals 10 is good. 7 lots of 2x minus 3 equals 17. Well, 7 isn't in the 17 times tables. That's going to be bad. Then we might consider this method. Now in the next video, we're going to look at some more expanding brackets and solving, as well as some more 3 operations, because this is quite a lengthy topic.